Okay, today I'd like to show you how to get equipotential lines sketched out using Desmos. I want to just remind you that the word potential is the same as the word voltage. The word potential is because voltage is related to potential energy. When you have a sensor and you measure a certain voltage or potential, that voltage is in comparison to 0 volts, which represents the voltage very, very far away from your charge. To calculate the voltage, hopefully you remember the formula. And what we do is we plug in Coulomb's constant. We plug in our charge, in this case 200 nanocoulombs. And we plug in the distance, which in this case you can see our sensor is 1 meter away from our charge. Notice e to the negative ninth cancels with e to the positive ninth, and we get about 1800 joules per coulomb. And that's how we get voltage from a single charge. We can plot out equipotential lines, which are all the spots in the plane that have the same voltage. So if you look, everything on this red line has a voltage of 10. All of these spots have a voltage of 20, and all of these spots have a voltage of 30. Once you start having multiple charges, your equipotential lines take on a much more dynamic and rich and complicated shape. You'll notice there are spots where the lines are close together, where the voltage is changing rapidly, and then there are spots where the lines are far apart, and that is where the voltage is changing gradually. If you walk along one of these lines, the voltage doesn't change, which means it takes no energy to move a charge around one of these lines. Okay, let's see how we actually calculate our voltage at some random spot. So let's put a sensor in a certain position. And then to get the voltage, we need to do it twice, once for charge 1 and once for charge 2. We just do the charge times Coulomb's constant over the radius. We have 9e to the ninth times whatever our charge happens to be, e to the negative ninth, because we're going to work in nanocoulombs. And then over the radius. These will cancel. So the only important thing is we need to find the radius. So to get the radius, we got to do a little bit of Pythagorean's theorem. We need to know the coordinates of our object, so we're going to call this x and y. We'll call this coordinate a comma b, and we'll call this coordinate c comma d. Okay, to get this distance, r1, hopefully you see that the x would be a distance of x minus a, and the y would be a distance of y minus b. So to get r1, we simply use Pythagorean's theorem, x minus a squared plus y minus b squared, and that would get us our distance. We would get the same kind of thing for the distance from charge 2 to this spot. Again, we make a right triangle. This distance would be d minus x. This distance would be this should be c minus x. This should be y minus d. So this distance, the radius, should be c minus x squared plus y minus d squared, and then we take the square root. Notice we can write this as c minus x squared or x minus c squared. It doesn't matter, because whether or not the answer is positive or negative, when you square it, it will come out to be a positive number. So our final result is going to look like this. Our voltage will be Cc times Q1 over the square root of x minus a squared plus y minus b squared, And then for the other charge, since we're getting the net voltage, we do the same darn thing. X minus c squared plus y minus d squared. Again, you could write it d minus y, c minus x, doesn't matter. Okay, so we're going to use this format to have Desmos figure out all the spots on the plane where our voltage equals a certain number. Hopefully you understood basically what we're doing here, and hopefully with Desmos this will become very easy today. So start by clicking here where it says start graphing. I suggest making sure you're logged in so that you can keep this in your Desmos account. You can go over here if you'd like and give it a name. Okay, and then in here what we'd like to do is create our charges. So we're going to put our charges at random spots on our thing. So we'll call the spot A comma B. That'll be the coordinate for it. Make sliders for A and B. Give it a label and call it charge 1. You should now see charge 1 on your grid. You should be able to move the charge around to any spot you want on the XY plane. I'm going to put my B at 0, and I'm going to put my X coordinate at 2. Okay, you can then make another charge, put it at position CD, make sliders, give it a label, Q2. This time I'm going to put it at -2 on the x-axis and 0 for the y-axis. I now have my two charges. Now I want to create a value for each charge. So I'm going to call Q1 equals, let's say, 5, and that will be nanocoulombs. I'm going to have that run from 0 to 20. And I'll be able to go up by 0.1. My second charge I'm going to call Q2, and I'm going to give it a value of 5 also, but I'm going to be able to go from, just like before, 0 to 20 by 0.1. I now have all my preliminaries, the strength of my charges, and the location of my charges typed in. I now want to do my voltage equations. So I'm going to be doing voltage 1 plus voltage 2. And obviously I can't just type them like that because it doesn't know what voltage 1 and voltage 2 are. So for voltage 1, it's going to be Coulomb's constant, which is 9e to the -9th, times charge 1. And notice how I did not put e to the 9th, because it will cancel with my nanocoulombs, which are e to the -9th. And then I take these two values, I make them into a group, and I divide by the distance that my sensor will be away from this charge. And using the Pythagorean theorem, I can do my distance as square root, which I'm going to bring up on my calculator here. And then it will be, this is for charge 1, so its x location is A minus the x location of my sensor, and then I square that, and then to that I add b minus y, and I square that also. I can then copy paste this for voltage 2, so I'm going to add voltage 1 to voltage 2. To change this to 2, I just put a 2 as my subscript. I change my A to C and my B to D. I now have voltage 1 plus voltage 2. I then assign it a value, such as 10. And what you'll see is a line show up on the screen showing you all the XY coordinates where the voltage would be 10. I'm then just going to copy this. Be careful you don't do what I did, which was delete the whole thing. So I'm going to copy this entire statement, paste it, and now I'm going to make it 20. That shows me all the places on my coordinate plane where my voltage is 20. And I continue to do this for however many spots I want, for however many voltages I want. And then I can simply take my charges and I can move them. And I can change the strength. And this will allow me to see my equipotential lines in a really simple and easy to calculate way using Desmos as my calculator.